In this video, we are going to discuss how to calculate the coordinates of the center of mass of a system of identical objects. The question says, a system contains three identical objects located in the xy plane. If the centers of the masses of the objects are 5, 2 for object 1, -1, 4 for object 2, 2, 6 for object 3, what are the coordinates of the center of mass of this system? So I have the coordinates of center of mass for the three objects. I need to find the coordinates of center of mass of the system. When they say identical object, identical mean that the dimensions of each object are equal as well as they have the same mass. So mass of object 1 must be equal to mass of object 2 and that must be equal to mass of object 3. So these masses we will call as M. All three of them have equal mass M. Let position of center of mass for object 1 be R1, which is given as 5, 2. For object 2 be R2, which is -1, 4. And for object 3 R3, which is 2, 6. I need to find what are the coordinates of the center of mass. Now the rule for the coordinate of center of mass is given as, if I want to find the x coordinate, xcm, it will be x1 m1 plus x2 m2 plus x3 m3 divided by sum of the masses m1 plus m2 plus m3. Now in this particular situation, the masses are equal. So I can write this m1, m2, m3 as just m. So we reduce the equation as x1m plus x2m plus x3m divided by m plus m plus m. We can take that m as common in the numerator, multiplied with x1 plus x2 plus x3 divided by m plus m plus m will give me 3m. Let's cancel off this m from the numerator and denominator. And then we are left with xcm to be equal to x1 plus x2 plus x3 divided by 3. Now this is how you can reduce the rule for center of mass for identical systems. Whenever you have identical object, you can directly find the center of mass by adding the position of all the object divided by the number of objects. So if I want to find x coordinate, I will add all the x position for that object divided by the number. So if I have 3 objects, I will add the 3 position x coordinates divided by 3. If I had 4 objects, I will add the 4 x coordinates divided by 4. So this is how you can reduce your rule for any system that has identical object. So let's calculate. I will get xcm to be equal to x1 is 5, x2 is -1, x3 is 2, divide by 3. That gives me 6 by 3. So x coordinate of the center of mass is 2. We find the y coordinate in a similar manner. So I write for ycm. I did not repeat all the steps. I already know if they are identical. I can just add all the y values divided by the number of objects. So y1 is 2, y2 is 4, and y3 is 6 divided by 3. That gives me 12 by 3. So y coordinate of the center of mass will be 4. So now I can write for the position of center of mass R to be equal to 2, 4. So this is how you can calculate position of center of mass for identical object. You can just use the simplified version of the rule where you add all the coordinates together divided by the number of objects.